now what they want us to do is they want us to come up with coterminal angles for each of the negative angles. So it's just like regular standard angles. Pi starts here and goes this way. Negative pi starts here and goes this way. But other than that, it's the same thing. So if it's negative pi and I go this way, what's its coterminal angle in the positive world? What is the same spot? I have to do my little thing. Okay.
Dance.
This is negative pi. This is positive pi. So what's coterminal with negative pi?
Positive.
Positive pi. Yes.
Good job.
Right? All right. So negative half pi. Well, positive half pi is this. So negative half pi is that. So what is it coterminal with? 3 pi over 2, or 3/2 pi. Okay, so now, negative 5 pi over 6, the way I like to look at this is, what is it close to? It's really, really close to 6 pi over 6, right? And negative 6 pi over 6 would be all the way to here. Negative 6 pi over 6 is just negative pi, right? So negative 5 pi over 6 doesn't go quite that far, which means it's right here. So what is it coterminal with?
7 pi over 6.
Yes. All right, same thing with negative 3/4 pi. It doesn't go all the way to 4 over 4 pi. It's close, though. So what is it going to be coterminal with? So negative 4/4 pi would be all the way here. But I don't go quite that far. I go to here. 5 pi over 4. Negative pi over 3 is just right here. At 5 pi over 3. All right, are y'all sort of kind of okay a little bit?
Hold on a second. Wait, how do those numbers correlate?
Which one?
E.
So negative pi over 3. So remember, you just start in the standard position and you go backwards. Well, negative pi over 3 is just barely up. So pi over 3 is just barely down. Negative pi over 3 is just barely down. And so I have to look for the one that has a 3 on bottom. And it's 5 pi over 3.
Oh.
Oh, okay, hold on a second. 5 pi over 3. These are all the opposites. Can you move the page over to the right?
They're the coterminal angles.
So it just the opposite, right? Opposite side of the circle.
They start on the opposite. Yeah, they start going the opposite direction. Yes. All right. Now.
Wait, I'm still copying it down. I'm sorry, I was coloring in the circle so I can remember. I was going to make sure I had it right in my head. You can go.
Okay, so now this right here to me is why reference angles, or why radians are easier than degrees. So remember when we talked about reference angles with degrees? Reference angles were when we cannot, the trigonometry that we know how to do so far is right triangle trigonometry. You cannot make a right triangle that has an obtuse angle in it. It won't work. That's too many degrees inside the triangle. So when we had angles that were this big, remember, we would draw back to the x-axis and we would use this angle as our reference instead of the whole angle, right? Yes. Remember that? Those are reference angles. Well, the thing that we learned about reference angles is that they're always acute and they're always positive. So we're going to do the same thing with reference angles for radians. It's no different. So if I am going to look for where 3 pi over 4 is, first of all, I have to think in my head, I'm going to divide my pi into 4 pieces. So that's 1, 2, 3, 4. Those are my 4 pieces. Pi over 4, 2 pi over 4. This is 3 pi over 4 right here. So if I look at that angle, that's an obtuse angle. I don't want the obtuse angle. I'm going to draw from here back to the x-axis and use the reference angle. And the reference angle is pi over 4. Because it's always the one that comes from quadrant 1.
That's it?
Yeah. So now let's do 2 pi over 3. So I'm dividing my pi into thirds. So that would be here and here. That's 1/3, 2/3. So this is 2 pi over 3 right here. But that's an obtuse angle.
So it'll be pi over 3.
It's pi over 3.
So
I could go to 6. That's right here. That's 5 pi over 6. But that's an obtuse angle. So instead I'm going to use pi over 6.
So it's just pi with the denominator that's the same?
Yep. Pi over 4, pi over 6, and you do not even have to think about it, except the only thing you do have to think about is where does it end up? Because I still have to apply all students take calculus. So I still need to know where those angles are, but to me the easiest thing to do there is go, okay, well, this right here, pi, that's 4 pi over 4, 3 pi over 3, 6 pi over 6, 12 pi over 12. I can get everything in reference to that. This right here is 2 pi. So that's 12 pi over 6, 6 pi over 3, 8 pi over 4. You just double the top. And I can get everything in reference to that. Does everybody understand what I'm saying?
Yes.
Sort of? Okay, so now, with that in mind, I want you to remember the little chart that we learned. So, sine, cosine, tangent, and our angle measures that are important are 30, 45, 60. Or, now watch this, these are the important ones. Pi over 6, pi over 4, and pi over 3. This is how you remember them. The only one of the special angles that has a 4 in it is the 45. It goes with pi over 4. The other two are swapped. 6 goes with 3, 3 goes with 6. And the chart doesn't change. It's just like it was before. So all of that stuff is just like you learned it before. So if you didn't learn it before, learn it now.
Hey,
Because you still need to
This
know.
is one of the only things I actually did really great on.
Okay, so now,
I know this one for sure.
before we do this one, because this is kind of just a little brain thing, we'll go to that in just a minute. Let's do this one, cotangent of 2 pi over 3. First of all, what quadrant is 2 pi over 3 in?
Be in quadrant 2.
It's in quadrant 2. Think about you cut your pi into 3 pieces, 1, 2, 3. So it's in quadrant 2, and my reference angle is going to be pi over 3. So cotangent of pi over 3, well, tangent of pi over 3 is square root 3. So cotangent of pi over 3 is square root 3 over 3. And in quadrant 2, is cotangent negative or is it positive? In quadrant 2?
Oh, yeah.
It should be negative. The only thing positive over there is sine and cosecant. All right. Where is 5 pi over 6?
Quadrant 2.
Quadrant 2 again. Pi over 6 is my reference angle. So what is sine of pi over 6?
It'd be 30 degrees. Right? Pi over 6.
Mm-hmm.
And then it'd be 1/2.
Mm-hmm. And in quadrant 2, sine is positive. 15 pi over 4. Now think about this one for just a minute. This one has gone around the circle several times. Almost 4 full times. If it was 4 full times, what number would be on top?
16.
Well, it's not 16 because it didn't quite go around 4 times. So what quadrant am I in?
4.
Quadrant 4. So secant of pi over 4.
Which would be pi over 4, which would be 45 degrees. The 2 over the square root of 2.
Right, which simplifies, rationalizes to square root 2.
Yeah.
And in quadrant 4, is secant positive, negative? What is that?
Negative.
All students take calculus. It should be positive.
Oh, sorry, yeah. It's the opposite of cosine.
Are y'all okay?
Yes.
Is everybody getting it? Okay, so real quick, let's do this one. Angle theta is an integer when it's measured in radians. It's right here. We see it. It terminates in quadrant 2. So I'm going to write some notation that you're going to start seeing a lot. I'm going to say that theta is between pi over 2 and pi. That's just a way for me to say that it's in quadrant 2. Now it says angle theta is an integer. Integers are whole numbers. And it's integer when it's measured in radians. Well, in radians, pi over 2 is, well, let's see, pi 4159, et cetera, et cetera, et cetera. And pi over 2 is like half of that. So what that's going to be like about 1 point, yeah, 1 point, I don't know, whatever that is, 1.57 something, et cetera, et cetera. So I need a whole number between 1.57 and 3.14.
2.
It's either 2 or
3.
2 or 3. Which one is this closer to? 2 or 3? It's closer to 2. So that's 2. All right. Are y'all okay? Everybody good?
When does assignment due?
It's due Wednesday.
Oh, okay.
And there's, I think it's got 20 problems on it.
So I'm doing tonight. This week.
I don't think it'll be that long, but.
Kind of hope so, kind of hope not.